Now we will go to the next problem. So this is the problem of showing a set is a subgroup of GL2R. Now what is that set? That set H is the collection of all matrices which are having diagonal entries A and B, and both those entries are not equal to 0. So we will collect a set of all diagonal matrices where the diagonal entries are not 0 in the set GL2R with respect to the operation multiplication. Now this R means A and B are real numbers. Okay, so how do we show this? So we will take two elements of this set. So let us take a matrix A, which is A1 0 0 B1, and another matrix B, which is A2 0 0 B2, and then we will, so both these matrices are in the set H, means the entries A1 B1 A2 B2 are not equal to 0. So these entries are not 0. Now we will multiply them. So when I multiply them, I know that if I multiply two diagonal matrices, the entries on the diagonal will multiply each other. So I will have A1 B1 A2 B2, the rest is 0. And what is the product of these two matrices? The product of these two matrices AB will be equal to A1 A2 0 0 and B1 B2. So this is, again, this entry is not equal to 0 and this entry is also not equal to 0. Therefore this multiplication of matrices A into B actually belongs to H. So the closure part is done. So let me write here, this was our closure part. So the closure is satisfied. Now for showing a subgroup, we did not check the associativity because we have a theorem. So we will directly check the identity. So does the identity exist? So what is the identity of this particular group? Clearly we know that identity matrix, which is 1 0 0 1, this belongs to H because A into any identity matrix will be again equal to A. So this identity will work for us. Then the third is the inverse. Now what is the inverse of a matrix of the form A0 0B, where A and B are not equal to 0? So clearly the inverse of this matrix is 1 over A 0 0 1 over B, because A into A inverse will be equal to exactly the identity matrix. So the inverse matrix also is a matrix of set H, because 1 upon A and 1 upon B are well defined, A and B are not 0, and this is also a diagonal matrix. This is also a diagonal matrix. The product is also a diagonal matrix. So closure, identity and inverse, all the three properties are satisfied, and therefore this means that this H will form a subgroup of H of GL2R. So H is a subgroup of GL2R with respect to matrix multiplication. This completes our problem.